That was Uncle Leo saying hello to you guys.
Hello, welcome back to Tutoring with Abdul. And today's session we'll be talking about examples on hexadecimal numbers. We'll be talking between hexadecimals and then converting back to decimals, then binary. These examples will be the word example. So we have some word converting between hexadecimal to binary and decimals too. So let's start up, guys. Since we talked about hexadecimal number already, we know what they are. Just to recap, hexadecimal numbers are the number that have 16, base 16, and they start from it shares two combination of numbers. 0 to 9 is decimals, and from A to F, we call them as hexadecimal letters. So we are together. We have 16, starting from 0 to F. And let's do some examples here. Example number 1, it says, try to write cafe as a decimal numbers. In the previous lecture, we did talk about how to convert between hexadecimal and the binary, and the hexadecimal and the decimals too. So we will just recap those questions, and we will put those wording into the example live. So let's go ahead and find out how we do it. Before we solve this example, let's see. This cafe is consisting of 4 alphabetic letters, C, A, F, E. We said in hexadecimal number, A is being 10 in decimal, B is being 11, C is 12, and D is 13, E is 14, and F is 15. So the value of these numbers are given in that table. We'll be talking about that table next. So how we solve it, we already did a couple examples in previous lecture, as we said. But in this one, we will just go recap. So let's go. First of all, we will have to write down this placing value, because start from 1. Then 1 times 16 is 16. 16 times 16 is 256. And 256 times 16 is 4096. And that times 16 is 35,536. 35,536, if I'm not wrong. And we can go back all back and forth there. Since we only need 4 digits there, 1, 2, 3, 4, so we only have to find the 4-digit placing values. So the next step is to put every letters below that value. That's how we do it. Will be C, A, F, E. The next step here is to find the value of this number and then multiply with that placing value and add it to the next letter, and do the same thing, multiply, find the value and multiply with that placing value, then add it to the next number, then find this value of the letter and then multiply by placing value, and do it until we're done with the questions. So we said C is 12 in the table, and we will be talking about that table next. There is a table that I've posted on this PowerPoint. So 12 times 4096 plus this number, this A is 10, 10 times 256, and plus this number, this letter, which is 15 times 16, and plus this letter, which is 14 times 1. So multiplication, when we multiply these two numbers, we get 4900, 4900, sorry, so 49,152 plus 2,560, or 2,560, and that will be plus 240 and plus 14. So these are all our numbers. So that's 49,152, 2,560 or 2,560 plus 240 plus 14. That will give me 51,966. Base 10, that's a decimal number. So the word cafe has equivalent to 51,966. Alright, so this is the first example. Okay, let's go and look at the table that I was saying. Let's talk about that. table. Okay, time for look up the table on conversion. Okay, let's go. No, not that table. I don't know how did I put that table there. No, 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 not that table. That looks like a good table, but we're not talking about this table too. That table is, it looks like delicious because it's the food in there. Table is not delicious, but the stuff that look on the table, it look like food, I think. I don't know. What do you guys think? Okay, that not that table too, guys. Sorry for that. Okay, so Mr. Doc says like, okay, here is finally the table has arrived. All right, there we go. That table. So the table is here like decimal numbers. So we talk about decimal. There is a binary conversion of that number, and there is a hexadecimal number here too. I talked earlier because 0 to 9 they share the same value between hexadecimal and decimal, so they're exactly the same, 0 to 9. From 10 to 15, they have different numbers. These are numbers and these are letters. So the symbols varies from 10 to 15. So we talked earlier that C's value is here 12, and A is 10, and E is 14, and F is 15, and that's where we get it from. There's one way, easy way is to memorize them. The second way is to look at the table. Sorry guys, I need to drink my coffee, it's too early. Okay, so that's the table. That's the table I was talking about. Finally, we got there. Okay, moving on to the example. Example number 2. It says no one understands hexadecimal numbers, but only the dead people. That's that's suspicious. Okay, so how many people understand hexadecimal numbers? Or how many dead people are there? Okay. So as we said, we just have to find the word, or what we said where was that? Okay, the dead word. So the dead word is D-E-A-D, dead. So we gotta find the placing value. That's a 1s, 16s, 256s, and 4096. So how we get it is 1 times 16, 16 times 16 is 256, 256 times 16 is 4096. And then we find the value of this D, E, A, D, each letters from the table, and then we multiply by that placing value, add it to the next number, and do the same thing with all over every letters and the placing value until you get the number. So multiplying these all numbers, D is 13 times 4096, and that would be giving 53,248. And this is E is 14 times 256 will give me 33,584. A is 10, 10 times 16 is 160. And D is again 13, 13 times 1 will give me 13. If you add them together, they will give you 57,005 people are actually dead. So only 57,005 people understand hexadecimal. That looks suspicious. I think it's more than that. But according to this questions, only that many people understand. But this is a funny question. It says like only dead people understand it. So that's not true, guys. Don't forget that too. It's just an example, okay? So hope that's easy. It's a word example because we can use it how to manipulate between wording and the decimal numbers. Okay, guys, moving on. Example number 3. What number did Shakespeare use in his famous code? Okay, Shakespeare is a famous man. So what did he use in his famous code? Solution is Shakespeare used the word to be twice in his famous code. Maybe more than twice that I know. It's the code says to be or not to be. That is the question.
Okay, here so Shakespeare used B twice in that code. So just to find B is a hexadecimal letter, and E is also. B is equivalent to 16. I'm sorry, B is equivalent to 11 in decimal, and 11 times 16 is 176, plus E is 14, and that multiply by 1 will give me 14. 176 plus 14 will give me 190 as a decimal number. So Shakespeare used B, which is equivalent to 190 in decimal numbers. That was not bad. The previous example, this we talked about. Let's move on to the next example. Okay, changing gears and shifting it forward. There we go. Okay, it says example number 4. Is Dad hexadecimal? What? Okay, let's see what it says. If yes, find the decimal value of it. Um, the answer should say like, okay, Dad is DAD, and that is consisting of hexadecimal letters there, DAD. And let's find the decimal values of that too. That's a funny question though. It's alright. That happens when you deal with hexadecimal number. So yes, the word that is consisting hexadecimal symbols, DAD, and here's the decimal value for that. So since it's 3 letters, where is the camera? Right there, 3 letters. So 1, 2, 3. So we have to find 3 placing value. It'll be time 1. That's what I talked about previously. You can do it this way, or so that will be easier to understand what that is. Time 16 times 256. That means this time that number, this time that number, this time that number. But of course we cannot multiply d by 1, but you have to find the equivalent value of d in decimal, then multiply by the placing value. So d has a equivalent value of decimal is 13 times 256 will give me 3,328. Time a is 10. 10 times 160 is 10 times 16 is 160. Plus d is again same number, 13 times 1 is 13. Add all these numbers together, it will be 3,501 is a decimal value of dad. That's actually dad, DAD. Not our dad, but it's dad. Okay, fair enough. Okay, moving on to the next example there. This dad says like, okay, I'm like not happy with that answer, but whatever. We got the answer. You can get smile, Baba. Alrighty, the example there is okay. God, what that was? Okay, just like bouncing around. Example 5 said, can you define babe as a binary number? That is a trick question. Is babe a binary number? It depends. So let's go. What answer says like there is an answer. Jump in actually. Okay, it's clapping. It says yes, it's a binary number. It is binary because BABE is consisting of binary. I'm sorry, it's consisting of hexadecimal numbers, and we can convert that to binary number. Let's see how we do that. For that, we have to write down each hexadecimal number representation in binary and then combine them all together. Let's see how we do it. All right, after memorizing or checking the table of conversion between binary and hexadecimal numbers, we get what we get. So B is equal to 1011, A is equal to 1010, B is again 1011, and E is 1110. So if you combine them all together, you get B, then you get A, then you get E, and then you get, no, sorry, B, then E last. So B is right here, and let me get my, what is that? Okay, so B is right here, and then A is right here, and then B is again right here on this point, and E is, as blue, use blue one right there. So BABE, babe, it's a binary representation of babe. So that's good. That's fair enough. Let's go to the next example. Okay. Oh, example number 6 says, is B binary? If it is, then find the binary representation of it. And that B is binary. If it is, then find the binary representation of it. Okay. One thing we know that BEE is a hex number, hex letters. B is being 11, E is 14, and E is 14 in decimal value. But we can find the binary value here. B is 1011, and E is 1110, and same thing with E. Then you combine these numbers. Let's use purple numbers just to make B excited. The B right there, and that's your first E, and that's your second E. So you combine them together, and you get that answer. Okay, B says, yeah, oh yeah, the B is a binary number. It says, yes, of course I am binary. Uh, and finally, it says, like, can you guys please leave me out of it? Yeah, we will leave you out of it. That's all right. So that's not a big problem. I hope these questions in these examples were helpful because we can find any any letter that consists, any name that consists from A to F. Okay, that's F. For example, uh, coffee is a good word, but it doesn't have O, but we can use zero there. So it'll be like C, zero, oh, it's not zero, F, and F, and E. Come on, come on, there we go. Okay, that's a weird kind of E, but let's see, that's fair enough. We can understand that. Okay, there we go. That's E. So coffee, we can probably find that one because that will be 1, 16, 256, 4,096, 35,536, and that is a huge number. I can't say that out of my memory. So you can find these numbers by placing value and then find the decimal in binary number. If you guys can find the coffee for me, that'll be great. And please practice. It's not that hard. You just need some practicing. And until then, guys, take care and be safe. And do not forget to subscribe this channel. It's me. I had to come with a video so you guys can see my face too. So that's actually me. Alrighty, guys. Take care.